Hi everyone, it's Mr. Barden here. Today, this video is going to be the first one of probably three, we'll see as we go, parts about just building a game from scratch that's including all of the stuff that we've talked about so far. So, we're just going to kind of hop right into it. The last time we did this, it was with a program, the Paint app, that's part of my classes. And if I just hop over to my convenient little bookmark there, you can learn more about that particular one. Is that happening here? No, it's the early in the graphics. Got that a little backwards. Paint app. There it is. You can find out a little bit more about that original app right here. And it's again, drawing based. So you click and it'll draw your colors and, woohoo. The one we made had a little bit more functionality to it. But for the most part, it was there. That newer version had sounds, it used sprites, interactivity with all of that. A lot of fun. What we're going to do with this one is build an actual game, because while the other one was fun, I would hesitate to call this a game. It's more of just a functional app. But so for a game, we're going to make something that's a little bit more involved. And I keep saying the word game a lot. Let's just define that real quickly. And it's, something you play. It's made to be for fun. It has multiple states within it, different scenarios essentially that you could find yourself in. And the most important bit is that it has a state where you can win the game and where you can lose the game. So being able to control a sprite entity in an environment with all of those settings, we're going to start putting together. In the next video, we'll start implementing the graphics and the sounds, and then a little bit of automation to wrap it up. We'll see how many videos that takes. I'm thinking it'll be 3, but we'll find out. Today, though, my goal is to get a working game, without all the, stuff to make it pretty, to have all the functionality there. So I've got this sketch right here, which has, if I go over here, everything we need already loaded. So we've got the normal P5.js. That's great. Down here, we've got the things needed for version 3 of P5 Play. If you're just going out of the textbook materials, a lot of the P5 Play stuff and all of that may be over some of the older versions of the library. So if you're going directly with all of that, there may be a little bit of difference there. But we'll get to that as we move along. So again, version 3 is the newest version, 3 point whichever we're on now. So because that's all brand new and it's still actively being developed, I've got the website pulled up right here, so we can hop over to that for anything. Okay, we're on 3.5.21. And basically, it's just in case we run into any issues. I've then got this last one in the middle that has tone, so when we get to all the sound stuff, we can do that. But today, we're going to generally just be focusing on the sprite library. Let's just tidy that up a little bit. Save. So that's what I've got there. This starting sketch is in the description down below. So you'll find that there. Because this is a project I'm going to have my students be doing along with me, I'm like last time when we did the Paint app, I'm not going to give the completed code at the end of each video, but if you go along with me through the video, you'll have it. And then after everything is done, then I'll present the final one. So with that being said, let's make one quick change here. I'm going to change this from being named My Sprite to just Player right there, because we'll start with the player. So I'm just going to save that and duplicate it. This is part 1. There we are. So this sketch right now will be in the description below. Before we hop into all of the coding for real, though, if you enjoy the video, enjoy the channel, you learn stuff, definitely like, comment, subscribe, all the normal YouTube things. We've got a bit of a cold front coming through here, so I may periodically be sipping from my tea as we go. It's still a little hot. I didn't make that as slurpy as I wanted. But yeah, just stay warm if you're in a spot that's a little bit chilly right now. So let's talk about the game as we start to code. So this game, it's not going to be the most in-depth thing in the world, the most boundary-pushing AAA title. It's going to be nice and straightforward. So with this one, the goal will be to navigate around the playing environment, avoid enemies, and collect items. And once you've got all the stuff, the level's over, you win, you go on to the next one. It's a little bit harder. That's going to be the goal, at least. So get nothing super crazy, but it's going to be there. I'm going to just immediately start by making the canvas bigger, twice as big in each direction, just so we got plenty of room to work. And there's my player sprite to begin with. It's going to stay as a square. In the next video, that's when we'll start adding in images and sound. We're just getting everything functional. But what we can do, player.color can be a new color, and we can make it be the same thing every time. I kind of like this blue, so I'm going to pick something, I don't know, that's very blue. So sticking a little bit of red, mostly green, and a lot of blue. Oh, I actually got it pretty close. It's just a hair darker. We're gonna, yeah, screw it. We'll just say, it's close enough. It's always going to be this color for our player right now. We've given it a default size and location right here up on line 5. You can change that if you want. In fact, I'm going to make mine a little bit smaller just so we have more room to work around. So that part is right there. So we've got our player. Now we're going to want to move him around the screen. That's kind of the first part. And I'm going to do this just by making a function move player. We've got that right there. There's a bunch of different ways we can do this, and I'm just going to say direction. It'll be there. And we're just going to set up a basic, let's do a switch this time. Switch, and then the case will be direction. And each specific case up. And I always get that backwards. Up will be a thing. We'll give it a value here and break there. So I'm just going to copy this, paste 2, 3 right there, and then we'll have a default state at the very end. So up, down, left, not there, that, left, and right. This is a 2D game, so those are, and we're looking at it from the top down, so those are really our only options. You could add some diagonal movement if you want, but I'm going to make life simple for this. So I'm going to hop over to learn, and we're going to look at the sprite stuff specifically, and we're going to hop over into moving the sprites. So we can just say specifically, that's the physics, not the sprite movement. Here we are. So we have a bunch of different options. We can give it speed and movement. That's great. We can use keyboard things there. We can specify, move options as well. So let's go into that. So if the case is up, down, left, or right, actually this has a lot, distance, direction, speed. we could probably, we'll do it like here with the direction plus speed. We can actually utilize some names here. There's other stuff like with the move method and all of that that could make things a little bit easier. But again, this is a new version of the library. And I'm going to do with what I prepped. So you could explore multiple ways to do this. So player dot direction. Oop, that should be uncommented. Equals up. Player dot velocity equals 2. They use 2 here. What is that? We'll make him go a little bit faster. We'll say 5 is the default speed. Get that right there. So I'm just basically going to copy and paste this each time. Right there. And its default velocity will be 0. And we'll just change this to match. Down, left, right. Ooh, I'm sorry, that one should have been right. All right, let's tidy that up. So what this will mean is whenever we call this function, we're going to give it an argument right there, and that'll be the direction. It'll either be up, down, left, or right. Those are the options that we have to give it. If we give it anything else, the sprite's just going to not move. We're going to set its velocity to 0. So we're just telling it, hey, when we tell you to go up, we're going to move you up at a speed of this many pixels per frame. And then we just change that around. So let's get that going. I'm just trying to think. Let's do it in the draw function right here. By doing this in the draw function, I mean you can hold down the button and move it around, move the player around. If you did this in something like a function key press, you'd have to push it every time you wanted to move it. Yeah, we can play around with that. There's, again, different options. So just say if, and we can actually, in P5 play, utilize this right here, this if keyboard dot presses left, up, right, or down. And actually, this one right here, I think we'll use pressing. To look at this in a bit more detail, we can go to input. So KB for keyboard. If we press it, if we're holding, we'll probably go with pressing in there. So let's hop into this. I'm going to just copy this, to be honest. We'll paste it there. So if we press up, then we will run move player in the up direction. Else if, and I mean, a lot of this is going to be repetitive. So we'll just do it like so. And instead of moving up, we'll go down. And down. Copy. Paste for not felt, F-L-E-F-T. And we'll move L-E-F-T. Paste that again, and we'll now go right. The order doesn't necessarily matter. Tidy that up. It's just going to go through an order. So now we'll test it out, see what we've got. If I hop over here. Okay, so that did not like that. Why didn't you like that? Let's see if we can swap it to presses. See if that'll change it. Huh. Doesn't like that, and I'm using both of the options. So let's hop back over to here. So keyboard. Well, I guess we can just utilize this instead because not 100% sure where that error was happening, but we'll just borrow some stuff. Okay, why is the player not moving? The player exists here. What's going on? Why isn't the sprite moving? Did I miss something? Oh, it's right now it's not working because I didn't give it a direction or a speed, I should say. That's at least part of what I'm missing. So, let's just say let speed equal 5. This way we can change the speed later. So now, nope. Yeah, that'll work. So now it's not going to move by default because it doesn't have a direction to move in. But then, there we go. So when we let go, because it doesn't have a direction or a speed to move in, it gets set to 0. And then it'll just kind of stay there. So let's slow it down. Let's make it 3. Yeah, that feels workable. Nothing too fast. All right. So we've got that part right there. That's the first part. I guess we don't need function move player anymore, but I'm just gonna comment it out and we can delete it at the very end. We'll keep it there. In fact, if we wanted to tidy this up, we could even just take all of this and replace it here. And then just call move player. And it should function the same. There we go. Okay. So we've got that one there. Let's make the objects to collect. So we'll call it the keys. Let's have it start off with 3 keys. Why not? And so the goal is for the player to collect the keys, and then they, can get to the next little bit. So we'll also define it up here with this key right there. So what I'm going to do is I'm going to make a for loop. Just like so. And the reason I'm going to do this is just so I don't have to repeat myself. So we're going to start I at 0. And we're going to run this for as long as I is less than total keys. And actually we'll say we won't define it here, but we will boom, we'll give it a value at least. And then we'll say I++, there. So what we're going to do is basically make up all of the characteristics for all of these keys as we go. So this key is going to be a new sprite, like so. And we're going to stick this randomly on the screen. So the location is going to be random. We'll stick this in between, so it won't be off the edge at all. Between 50 and width -50, and then between 50, and then another random 50 to height -50. There we go. And then I'll make these circles. Why not? 15. Comma helps. So now, boom, it sticks the keys somewhere randomly on the screen. Let's make all of the keys the same color, so that way they're probably going to be the only circles for now, but just so we're used to them. I'm going to make them green, so that way we can kind of go to that. So this key dot color equals color, no red, all the green, no blue. Boom. So now they're all the same green color for right there. We can do a few more things when we hop into that. What I want to do is do a thing. How do we want to do this? If you can't tell, I had no plan going into this. This is literally all off the cuff. So just in case we need to talk to all the keys, let's also make all keys, and then we'll do this before the for loop. All keys is a new group, and then we'll say it's a new all keys dot sprite, and this will automatically make it and add the keys into the group. That way we can talk to everything all at once. Can I just say all keys? Hey, I can. Cool. So we can set the color right there. So I guess we'll set up what happens when the player interacts with the keys, because right now it just bonks into them essentially. Which is fine, but that's not really what we want. So can we just do it like this? All key... It helps if I don't hit that. All keys dot collider equals static. It does work like that. Cool. Okay. That's a fun way to get a little spin up there. So now what we're going to do is basically say what happens when they collide. And a fair bit of this is actually happening right here. So we can adjust a variety of things, but let's just find the collision specifically. There we are, I think. No. I thought it was there, but there we are. Colliding. There we are. So basically we just have to say if player dot collides with something, in this case all sprites, we can set that up. So let's make this in another separate function so we can pull it in and out as needed. And we'll call this function key check, or key collect. There we are. So I'm just going to hop right underneath my draw function there and function key collect. So what we can do is say, hey, if the sprite talks, collides, if the player sprite collides with any of the keys, we're going to collect it and do a thing. So, so let's see. All keys. I'd say let's do it like this, maybe. I'm just trying to think my way through this. All keys. That's a horrible name scheme, but keys remaining. Keys remaining equals total keys. So the first thing I'm definitely going to do, keys remaining, I'm going to decrease it by 1. If keys remaining is less than 1, then we will run new level. All right. New function new level, and we will come back to that when we get there. But the goal is to collect the keys, so we're going to collect the keys. So we want to say, okay, there's one less key remaining, and when we have all of them, then we win the level and we move on. We also need to remove the sprite. So let's see. So we got the colliding here. Basically, we just say if player dot collides, if player dot collides with any whatever we give it the sprite there. In this case, it will be for now we'll just say all keys. Then we're gonna do all of this stuff that we just specified. Tidy that up a little bit. I'll move on. So we need to remove that specific key that we have collided with. So what we need to do is say, hey, we need to figure out, is it colliding? And I'm just seeing what we've got left over. Not in particular. Scroll through all the things. Chain collide. I'm not seeing anything else that's hiding. So, okay. So we need to go in and talk specifically to that. And I'm actually going to pull up a sketch from before open. When we did that paint app, we had to do exactly this, and this was causing a lot of issues. So we're just going to pull open the video one. There it is. And find that part right there. So I ran into the same issue where I had to talk to a group, but then find in that group a specific sprite. So okay, so that's what we did there. So so let's try this. All keys dot for each. I'm just making sure I got the arrow. Yeah, it's just E. Layer, and then we'll say boo boo boo. Yeah, all of this. Paste it there. Remove it there. So this is what I'm expecting to happen. We're going to find out. So when we run function key collect, we're going to, for every key in function all keys, we are going to see if the player is colliding with that particular key, which we're just calling E for now, that element in the array. And if that's the case, we're going to decrease this value here by 1. We are going to say, hey, if it's less than 1, we'll go remove it. The other things we would want to do would say e dot remove. I'm going to double check that it is remove. Yeah, remove. I think so. Yeah, I think that'll be what we need. Let's just give it a shot and see what happens. I think it may work because we've already got that one already had 2. So if we move around and collide, boop, it goes away. Cool. All right. That'll boop there. And then it'll boop here. Then nothing will happen because function new level is empty. But we have now found a way just to simply collect all of the sprites. Cool. That's not a very pretty looking function, but it gets the job across. And we can tweak all of the things we have here as we go along. So for new level, we can say all sprites dot remove just for now, and we'll run the setup function again. That's what we'll do when it's a new level, but for now, we'll just leave it for there. We'll probably do a little bit more tweaking and setting of values as we go. Okay. So we can collect the keys, we can move the player. Let us let me think. Let's get some obstacles popping up on the screen. These are going to be just randomly placed walls. It's like a maze, but it'll be kind of randomly generated. I'm going to do this in a separate function that we can just call later. So yeah, let's say function. Let's do all of this in a separate function. Function make keys and function make walls. So I'm gonna take all this key stuff. Excuse me. Copy it. Put it there. We'll make the keys. Boom, just like that. So we'll set that there. We'll also run function make walls. We'll give it a number to make, I guess. We really don't have to because we're defining it all globally. So we'll leave that as here. Function make walls. So again, we'll do the same kind of thing with a for loop. So we'll say all wall, basically copying this for now, is a new group, and then we'll define that up top. All of the walls right here. So boom, and then we'll say for let I equal 0 for as long as I is less than a value. I'm just randomly typing in 4 for now. I++. So I want to be able to make as many walls as I want. So let's have the we'll run make walls, but with a specific value. Let wall number we want it to be a floored number. And we will run this to generate a random number we'll have a minimum of 10 walls and a maximum of 30. I don't know, I'm just picking some random stuff right there. And when we call this, we'll use the wall number. And instead of being less than 4, it'll be less than. We gotta fill that in. The number. Okay. So we can move along. Now I've got the rules, so this will run for as many times as we need it to run. So inside of the for loop, same kind of thing. Let this wall be a new sprite. There. Same kind of thing. It's going to be random, and we'll make all of these aspects of it random. So random is very fun when playing around with making things. I always include a random something just for a little bit of chaos, a little bit of excitement and unpredictability. So I'm just going to make these be a random width and height as well. So these will also be rectangles like the player. So let's make them a minimum of 10 pixels and a maximum of 300 in both directions. 10 comma 300. That should be a new all walls dot sprite. So I'll have that there. All walls dot color equals a new color. I'm gonna make this kind of brown, so that's a lot of red, fair bit of green, a little bit of blue. I don't know. Okay, they're there. We're gonna decrease that just a little bit, and we'll make this 200 by 150. Let's make it a maximum of 20. Okay, we're getting there. Let's make it 15, just so there's a little bit of variety to work with. We'll leave it this kind of weird orange color for now because it's going to change a bit later. But we wanted to make them. So we can do that. We can also say all walls dot collider equals static. So that way they, after they are no longer overlapping, they don't move. I'm going to keep them like this, so that way they don't overlap. It'll look more like a maze. Again, it's all randomized, so there's only so much we can do. The reason I'm making it random for this part is because I don't have the time or the patience to draw out a ton of levels and specifically place all the sprites where I would want, like you would if you were actually making a real game for a real company to sell and all that. This is more of an educational exercise, so we're just putting them on there. And then there are some games like that where you would play with randomizing stuff, the whole procedurally generated kind of thing. That's basically what's going on here, only our procedure is stick it somewhere and see what happens. So I'm not doing very good at slurping today. Okay, so now we've got these right here. I want the player to be able to bonk off of the walls. And that's what I think we're going to do. And I think there's a few ways we can do that pretty easily. If we hop over into Sprite, there was somewhere over here. Yeah, I picked that the first time. We got this player dot, this bounciness aspect of it right here. Boing, 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 boing. So I think if we just say, when we make our player, there we are, player dot bounciness can I'm just gonna pick 2 and see what happens. Okay, why did that move? That's because of the bounce, maybe? Boing. Hmm. Okay, I wanted these to not move, though. I think I forgot an L there. And it looks more like it. So if we bong, 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 or if we increase that bounciness. Bong, bong, Hmm. Looks like I think one thing I want to do to help with this is just set the mass. When we make these to be really, really high. It'd be really stupid high. Bong, 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 bong. There we go. So we're sort of kind of just bouncing off stuff, and this way, that can be a little bit chaotic. Maybe we don't want 10 for the bounciness. Maybe we just want. Let's look at 8. Bong. Let's see. It's a little more bouncy than I really want it to be. But we can fine tune movement later. It's a little more jumpy than I would really want. But we'll fine tune that. So they're displacing the things. That's what I want to. That's why. Stuff a flat surface. Here's a workaround that overrides after it collides with the ground. So that's convenient. We'll come back to this. It may be a thing. It's not really that much of an issue right now. What I want to do is working with the overlaps stuff. So, I want to do is make it so that they don't overlap. I'm just looking at all the options to make sure I'm not missing anything. Oh. Uh, okay, so maybe here. Kinematic can be moved. What just happens if I do it like this? Okay, so I think we can. We have that picked up a lot of physics. So I think what we can do now is by removing that all keys is static there, then we can avoid the walls overlapping with the keys like we had before, because we don't want a key in a wall. That's a bit problematic. So we have that happening there. I'll leave it commented out just in case we need to put it back. So I've got that there. I don't think I have Okay, so you see how this sprite up here is not a great example, but it's going off the boundaries of the screen. We got a bunch of them happening over here. Let's avoid that. Let's make it impossible to leave the boundaries of the canvas. So we don't want to have unintentional boundary breaks, because right now we can just do this. And if you... Okay, now you don't know where you are, and you're lost. So we're just going to make it impossible to go completely off of the screen. So I'm going to do this under make walls, because it'll make, well, life a little bit easier. I'm going to do it before we have this. So I'm going to do another for loop. That's not what I wanted there. Let I start at 0. I will be less than 4. I plus plus. Now, there's a ton of ways you can do this. I'm going to do it in what is, I guarantee, not the most intuitive or straightforward way. But I'm just going to do it this way because I know what it's doing. So if I is equal to 1, we're going to do a thing. That should have started at 0. Then else if I is equal to 1, else if I is equal to 2, else if I is equal to 3, we're going to do some stuff. What we're going to do is make a sprite. So let boundary equal a new sprite. We're going to make that to default, and then we will say boundary dot mass will equal, I don't know, 7 that much, a lot. So that way we don't have to worry about things. Boundary dot collider, it's going to be static. We should work with that. So if it's 0, we're just gonna label these top, bottom, left, and right. So if it's 0, we're gonna basically just make this sprite a whole bunch of times and place it on the top, bottom, left, and right of the screen. So boundary dot x equals width divided by 2, because the sprite gets drawn from the middle. Boundary dot y equals negative 20. Why not? Boundary dot width equals the entire width. Boundary dot height equals going to be 20 in each direction, so that should be 40. If we run this, we should see nothing change, but now why are you not going to the right spot? Oh, it's because it's making the other 3. I'm just an idiot. So we'll finish this up and then we'll test them. 2, 3, 4. So if it's at the bottom, then instead of negative 20, we will be height plus 20 for the top and bottom. Now, if we want the ones down below, we can say, I think we want static is what we want. We'll find out as we move along. To move it on the left of the side, we want this one to be negative 20. The y position to be height divided by 2. the width of it to be 40, the height to be the height of the canvas. This way, if we change the canvas, the boundaries stay the same, is why I'm formatting it like so. I'm just gonna, so there's less typing, I'll paste that part. So now with the X, we want width plus 20. That'll stay the same. That'll stay the same. So we got that there. That's a wonderful maze. And let's just see if I move up. There we are. So now it's impossible to move past these sprites. It's bouncing at a weird angle because I picked up a little rotation somewhere. Bunk, 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 and I'll test the bottom. Bunk, 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 bunk. There we are. So again, we can no longer leave the canvas. Very handy. So we have that there. I could have sworn there was a displace. I must be thinking of the older version of the sketch. That's okay. Of the library. So now we've got that. Let's add some enemies, I guess. So these will be little red circles to start with. So we have here, make keys, make walls. I'm going to move these down below. Copy, delete, paste. All right. Just to clean up some space, we also... Actually, that's still down below draw. Okay. So we're going to make some enemies. Let all enemies... I don't know what I'm doing. All enemies. There we are. We're going to run a function. You guessed it. Make enemies. We'll do that. And actually, what I'm going to do is I'm going to take this player making stuff, and we're actually going to put that at the bottom, so that way the player gets dropped in after everything else has been made. Make enemies. Enemy number. Copy this. I'll just make that enemy num to save some typing. So we get some random ones and enemy number. So now every level is going to be a random little bit of enemies. So let's make function enemies. Again, the same kind of structure where we're going to just make a whole bunch of the same kind of thing. So all enemies is a new group. I called it all enemies, right? Yeah. For let I equals 0. It's very repetitive at this point. As long as I is less than the number of enemies, I plus plus. We need to feed in that number from when we called it up on line 15. And now we can start making the things. So let this enemy equal all enemies dot sprite. Again, it's going to be randomly placed, so I'm going to go back down to my make walls, where we're placing them. There we are, and we're going to copy and paste some of this. Boom, right there. Key collect. There we are. And we're gonna paste those there. So they're going to be random, but we're gonna make all of them about the same size as the player. So I don't know, about 30. Oh, it didn't like that. I forgot the new. So that's their. Yeah, why not? We'll leave them. Kind of big. I'll make them slightly smaller. 25. We may make them rectangles later. Depends on the images we want to put on the things. This enemy dot color equals color. We'll make them red. Boom. Just so we can tell everything apart. Cool. So we've got the enemies. We need to move the enemies around. So let's make function move enemies. Then we'll just say, I think we can just feed in a specific enemy dot speed equals 1. Let's make it move a little faster. Enemy dot direction equals a random value between 0 and 360. Okay. Can I do it like this? I mean, we're going to find out. So let's hop into that draw function. We'll say move, not this. We will say all enemies dot for each say E in parentheses equal sign arrow braces. And what we'll do is for each, actually, we didn't even really need the arrow function. For that, we could just say for each, and then we'll run function move enemies. Will that work? We're going to find out. Did not like that, even though sprite. Movement, there we are. Yeah, we can set speed. So it, we may need to format it like that. Actually, it should just look like this. Doesn't need the parentheses. Okay, so we've got it. But now they're a bit more wobbly. How do I want to set this up? I want to have them pick a direction and move in that direction. So, I'm going to copy this line, and we'll do it after they've all been made. We're going to make a move just by default. And then what I think we'll do is if all enemies dot for each, and then now it'll be a nameless function. And we will say instead, if E dot collides with with any sprite, then we will run the move enemies function with that sprite. So what I'm thinking this will do is this will, again, when we make all the enemies, we're going to run the move enemy function. So they move, but we're only calling it one time after we've put all the enemies on the screen. So that way they don't get this kind of random jittery effect. And then when they collide with any other sprite on the canvas, they're going to change direction. Basically pick a new one, and it should. Yes. I didn't mean to refresh that, but all right. Now we've got some moving enemies. Again, it's all random. There are ways that they can pull up, and change a bunch of things. It is what it is. It's not the most exciting thing in the world, but I'm really excited that worked. So we've got that right there. So now we run into the issue of, okay, the enemies are bouncing off of stuff, and I like that they're bouncing the keys around. It adds another element here. Let's see what happens when the player and the enemies collide. That's what we're gonna focus on next, and that'll be most of what we're gonna do today. After that, it'll just be some logistic stuff, and we'll put some really basic UI information on the canvas as well. So, let's do this. Let player life. There we are. Player life equals, I'll pick 3 to begin with. We can tweak that later. So we'll have that right there. I'm just going to make function ouch. So this is what we're going to run every time the player gets, basically hits the enemy. So every time we do that, we want the player health to go down by 1. Health goes down by 1 if player health is less than 1, then we'll run function game over. To avoid an error, we'll say function game over right here, just so that way it doesn't run into a whole function game over is not defined issue. We just want to say that, hey, when the health hits 0, it's game over. That's usually how a lot of games work. We can do I was thinking of what we want to do. We could reset the position of the sprite, which could work, but because the positioning of the walls is random, that might be a bit problematic. It's definitely possible, but I'm trying to think of something quick I can do in this video. So I'm going to take a sip of my tea whilst I think. I need to get more soon. All right, what if this? Is there a value for that just by itself? RS doesn't look like it. I was hoping there'd be a way just to adjust the transparency. Image. Next, we can, stick an image on there. That's great. But and to animate it, that'll be what we do next class. I'm just seeing if there's a way to make it a little more transparent. Not really. Okay. So I'd like to make it transparent to kind of indicate, hey, it's not being hurt anymore. Well, so we're gonna do a little bit of searching. So JavaScript async So this is a thing. I forget why I did it, but it came up in one of my um, classes before. But basically, we can make an asynchronous function that's going to happen at a future point. I'm just seeing where's the. This may not be what I want. This may be what I want, but I don't think it's going to be exactly what we need. I mean, this could probably work, but I don't want to spend a whole bunch of time learning about that. So let's say, uh, for now, player. We don't want to put that there. We want to put it after that. So, player dot rotation speed. And we'll make the player spin. And we'll just have them teleport back to the beginning for now. We can tweak that later. We'll tweak that. But now if they get hit by an enemy, actually, I don't think we're actually calling this now yet. Yeah, we didn't teleport back. So let's do that. If draw function, where did you go? Draw. There we are. So you have that right there. So if player dot collides with all enemies, then we will run function ouch. So we have that right there. Okay, and that player health is not defined. What did I call it up top? Player life. Well, let's make it all player health. Player health. Player health. It looks like it'll probably work then. Boom. Yeah, then that teleported and now it spins. So let's make him spin a little faster each time, just for fun. Rotation speed, so we'll say plus equals 5, and that'll make it spin faster each time. It's something for now. Later on, we'll change something else. So we've got that there. So what I want to do is function game over. We'll just sprites dot remove. Well, for now, we'll remove all the sprites. So it's game over. You got to reset. I want to put a little bit of text on the screen that's telling you what to do. So let's do that. I'm going to tidy some of that up a little bit. Right there. So let's move some of this down. Ouch. Game over. Move enemies. Make enemies. Copy all that. Move it down. And I'll show you some other ways to set up all of that. So you notice everything disappeared. That's because boom, we 2, and the next one that intersects is be this one. Yep, 3, and it removed everything. Removed everything instantly. But for now, we'll tweak that. We could probably change that up a little bit. In fact, we could even just say player.remove keys.remove because I want to leave the walls there. Let's just see how that goes. Cool. Yeah, leaves the walls. Everything else goes away. And in fact, we could really don't even need to remove the other stuff. Okay. The text. So, where's my draw function? There it is. So I'm going to do this here. Function. I don't know. UI for the user interface. Why not? So let's put the text. For now, it'll be text. I'd like to do an image thing. I think there's a way we can do that, but we'll play around with that as we go. Once we've got all the images here. Actually, no. I'm gonna try to do it with the images. So this will have a bunch of stuff going on, and we can call UI every time, every frame. So let's start with the some text on the screen that just tells us what to do. Text. We can make it pretty. Center. Our text size Z, and we'll make it kind of big. Let me see. All of the keys to the next level. Cool. That's that. We'll put this just at the width divided by 2, 20, and it's there. I guess we'll put UI at the end of the draw function. Let's see if that'll put it on top of the sprites. I gotta wait to see if a sprite randomly is up there. No, it won't, but for now we'll leave it there. I think I want to make these walls smaller and have more of them. We'll go from there. So that's there. So now in function UI, we've made the text cool. I want to make some sprites. And put them on the screen, but then we could pull them off. I'm going to make a separate video about that. Instead, what I'm going to do is just put it on the screen with text. Just because I need to plan that out a little bit more. I'm going to format mine here. So, player health, $, bracket, and then we're going to look inside of the player health variable out of 3. It did not like that because I misspelled it. Player health. All right. Did not pop up because I didn't tell it where to go. 20, 20. $60, 20. 40. Move it down a little bit. Move it over a lot. There we go. Okay, that's something. It's kind of horrible. Let's put this down at the bottom just so it's not fighting. With that for real estate. So height -20. Save that. There we go. So that way at least they're not fighting each other. So again, this will probably be a separate video by itself. but I'd love to visually represent that. And if we wait again until an enemy hits, we should see this go down to 0. And because I'm going to suicide mission here. Boom. Yep. Okay, cool. So at 0, player disappeared. So 3, those all missed the player. 2, 1, 0. There we go. Okay. I'd like there to be a little bit of a cooldown between getting hits, but again, this is me thinking of ideas after the fact. There we are. So that's there. So let's do a few more UI things, and we'll call this one a video. So in function game over, we'll remove that. If I just say no loop, will that make it so it stops updating stuff? 2, 1, 0. Yeah, so it'll just stop. Great. And then can I also make it say text game over? Refresh to try again. 2, 1, 0. And I didn't tell it where to put the things, of course. Width divided by 2. Height divided by 2. Let's wait for me to lose. Or we'll speed that up a little bit, maybe. Oh, okay, that was some interesting physics stuff happening. 1. That's because it's teleporting back to the middle. And there we are. Okay, so that's there. Sprites are gone. So we'll... they're in the way. We'll leave it like that again. And adjust that. So we've got it stopping now. Refresh it's some things. So that's there. Back under function UI. There it is. Let's also say the score. Text. Player. We'll say keys collected. Because, I mean, you need to know the score when you're playing, as well as needing to know the health. I mean, it's nice to know how many enemies and all that, but since we don't really have a way to defeat and make less enemies, knowing how many there are isn't really needed. So, keys collected, colon space, $ braces. So, player health, keys collected. It's going to start at 0 every time, and then we want to monitor it through all the levels, so we won't define it here. We will instead say when we collect... Where'd my string... keys collected. And then when we go to the collecting the keys portion... Ouch. I don't think I have a function for collecting the keys, because it's just... Oh, key collect. It's right here. I just scrolled through it. So we have that there. So after we remove the key, we will say keys collected gets increased by 1. And I always forget to tell it where to put it on there. We'll put it on the other side. Okay. Boom. Not quite what we wanted. It's now counting every frame, because I forgot we're checking every frame if we're collecting it. So let's just go to... collected right here. So when we remove it... Yeah. When we remove it, we will do that. So now it starts at 0. And if I actually play the game... Boop. Nope. boing, it's 1. My health went down. Cool. Now I'm spinning because I can. Boom. That's going there. Then we're back here and it reset. Now we've still got 2 health. Fine. We've got, I've collected 3 keys. I'm currently pinned into that corner. Aha, got through. Boom. 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 Here we are. Okay, so we're going along. I must have appeared directly over oh no, it's hiding under the wall. So that's something we need to avoid, but we'll figure that out. Where I'm going to end it today is adding one more ending result. Or one more ending condition, I should say, for new level. Because right now it's just when they're less than 1, we just automatically make that. So what I think I want to do is have one sprite that is like the door to the next level. So you have to get all the keys and then get to the door. Because that just seems to make sense if we're thinking of it still as a key. So let's do that and we'll wrap it up. And then this has already been going for a bit. I may make I think I'll make it a separate video and we'll tidy up this code in a separate video. So let's do that. I'm just gonna say let door. Whenever we make a new level, I'll just say door is a new sprite. We got that right there. And then we'll put this, again, randomly on the screen. Where did I make my randomly placed sprites for the walls? Here we are. So I'll copy this. And actually, while I'm here, we'll make these a lot more smaller at only 100 pixels max. And then we will, when we call to make walls with the wall number, we'll say we can have, more of them. Okay. Paste that there. And I'll make it be the same size as a wall. Now that we've tweaked that, I should have recopied it. Tidy that up. And then door dot color is, for now, color black. So that was the door for the level. Cool. So we have that right there. So what I'm going to do is now, instead of saying if keys.remaining is equal to new level, we will then, so let me just find where that ends right here. We'll copy that. And I'll hop into my draw function. And let's say at the end, paste that there. If it's less than 1, we'll run new level. But instead of running new level, we will then say, copy that, if player dot collides with the door, then we'll run new level. So what this will do is it'll do all the things, it'll keep checking, and then it will say, hey, if we're down to 1 key, we will do the thing, and then if we collide with the door, actually, I think I'm going to make this even more optimized. So we'll do that, and we'll say else key collect down here. Ooh. So the way I've set this up now, and again, totally on the fly, is we're going to say if we have less than 1 key remaining, meaning we've got them all, then we will say, okay, if we collide with the door, then it's going to be a new level. Otherwise, meaning we have more than one, we're going to run that key collect function, which is just saying, hey, if you collect the key, do this over and over again. This way, we're only running key collect when we know that there's more keys to collect. As soon as we get all of them, we'll stop checking that, and then that'll save a little bit of CPU. Okay, so that was a lot of me doing some typing and trying to figure things out. Again, to briefly go through everything, we've got a player sprite that is the blue square for now. Again, in a future video, these will all be, I'll have images on there, so it'll actually look like something. But it doesn't necessarily have to be. I realize my door is moving, so we should say door.collider is static. Save, tidy, save. We got that there. So, got all of that. We can move the player with a function called move player, which just says, hey, whenever you press up, down, left, or right, and that's the arrow keys or the WASD. Right. Arrows or WASD. We'll move it, and if nothing's getting pressed, we're going to set it back to 0. We've got some obstacles, some walls in the way. They're just being randomly placed and all of that. We've got other walls that we can't see that are keeping everything on the canvas, so that way nothing disappears. We've then got enemies right here. These ones, and they're just randomly moving. And whenever they bump into one sprite, they're going to pick a random direction and move off in that. They're not the most intelligent things, but they're going to serve our purposes. When the player collides with the enemies, then the player health goes down, and if it hits 0, it's game over. And then just to indicate some of that and hopefully get the player out of the way of more damage, we're going to make the player start spinning just to indicate visually what's happening. And then we will just teleport him to the middle. I want to figure out something a little bit better to do, but we'll figure that out as we go. When it's game over, the game looks like what we have right now. So that's there. Making the enemies, moving the player, making the walls, making the keys. So the keys just exist, and basically it just serves as a flag. So once all of them have been collected, then we can interact with the door. Otherwise, nothing will happen when we touch this sprite. It effectively is just a wall until we collect all of the sprites. We'll make that look a lot more exciting when we add all the images. I've got some ideas so we can actually make it look like a wall and then change and look like a door once we've got it. But anyways, we'll talk to that when we go. New level, just when the new level happens, we just get rid of all the old sprites and rerun the setup function. So then that'll set all of the default stuff and generate new numbers and all that right here. And then we've got a function for the UI that's giving us this information. We'll make it a little bit more pretty as we go, but for now, that's what we've got. So yeah, that's where I'm going to wrap up this one today. I think in the next video, we're going to look at it's going to be significantly shorter than this one. It's just going to be a lot of tidying up the code in order to make it a little bit more readable, because we're going to have a lot of moving parts by the time we're done. So hopefully we didn't go too fast. I'll be also adding in some comments describing what everything does in that follow-up video. The starting code and all the reference pages we looked at will be in the description down below. So definitely give it a shot. Try to make your own version of this. If you do, definitely share it in the comments. I love seeing what people make. And I think that's where we'll end it up. So stay tuned for the next one. And again, by this point, probably 3 or at least 4 videos now, we'll have a complete game with all of the normal things you might expect. So stay tuned for that, and I will see you all the next time that I see you. Bye.